Good morning. It's so exciting to be here. What a spectacular facility, and this is an amazing university that's doing something really important by bringing together scientists and engineers and public policy and the community together. I want to talk to you a little bit about what's happening with the Global Resilience Institute. If there's a theme that's been walking across what you heard from Carla Broadley and David Lussey and Jeff Trussell, it is this whole issue of interdependency of the systems, of the networks, and of the communities that we rely on. Now, one of the challenges that goes with all that deep interconnectedness is the interdependency that also is involved with that. And if we have a shock in one location or one node, it causes cascades across those systems, often and potentially resulting in catastrophic failure. This is the resilience challenge that we need to be taking on. Now, part of what we're wrestling with is that the networks that we have built, the systems that we have built in the 20th century that support modernity, these systems were built for efficiency. In some cases, were built for safety, but they weren't built for security or resilience. That is, the architects that built the foundations that we rely on for our modern way of life, those architects didn't really think about what if somebody with malicious intent targets the systems that we're building? Or what if we have a shock, how will the system better withstand and recover from that shock so that we assure the continuity of function? That is our challenge, is to figure out how we now both retrofit resilience into systems that weren't built that way, as well as we innovate and go forward, how we make resilience a key element of that effort. Resilience is something that resonates with us, but what's keeping us from getting there? Well, first is a really tricky science problem. We have to understand these systems, their interdependencies, their interconnectedness, and how shocks can affect on them. Second, we don't design for resilience. So that's a really important engineering issue. How do we design systems not just to withstand a shock, but to be able to essentially fail gracefully, recover nimbly, and adapt going forward? That's a really challenging engineering problem. And then we have to scale this in a hurry. That's going to require incentives. That's an economic and business challenge. Fourthly, we're not organized to do this. We have to find ways in which we pull sectors together, where we put people across multiple jurisdictions to get us to where we need to be. And that's a governance and a public policy problem if I ever met one. And then finally, we're not in training and educating the future practitioners and researchers in this. And that's obviously an interdisciplinary educational challenge. It's going to take a lot of collaboration. And collaboration's got to go beyond just in the university. We have to collaborate with practitioners in the public sector, in the private sector, and within civil society.